Good afternoon. Okay, so some of you know me already. I'm the maintainer of the Linux Manual Pages project. I've been doing that for a while now. I wrote a book as well on Linux programming. I do training work as well. I'm going to make some assumptions here. One is that you already know a bit about control groups, C-groups. You have some background understanding what they do, because I'm not going to talk about that as such. And you know roughly how Cgroups version 1 works, because what I want to talk about is what's different in Cgroups version 2. So I'm going to talk a little bit about the rationale, why Cgroups version 2 came into existence, which is really a story of what are the problems with Cgroups version 1. A little bit of a discussion of the controllers that are available in version 2 versus version 1, and then some details on the difference of how version 2 operates compared to version 1. And then if we've got some time, some additional topics I will try to get through. Further differences in Cgroups version 2, which is release notification, delegation, and thread mode. If we've got time at the end, I'll take questions, but I've got a fair bit I want to try and get through. So the reason we have Cgroups version 2 is because Cgroups version 1 turned out to be an almighty mess. Basically, there were a whole bunch of controllers added in Cgroups version 1. They were added by different groups of people. There was no coordinated overall design, and after about 3 or 4 or 5 years, people realized this is an inconsistent mess, and the only way of fixing it is to start over. And so about 5 years after the appearance of Cgroups version 1, people started working on Cgroups version 2. That was eventually released in 2016, early 2016, after quite a long development phase, about 3.5 years to get that work done before they made the official release. You can use Cgroups version 1 and version 2 on the same system at the same time, subject to some limitations. The most notable limitation is you can't use a controller in both version 1 and version 2. You're using it in one version or the other, but not both. There's some other places you can go and look for information about Cgroups version 2, in particular the documentation file and the kernel source code. And there's a reasonably good Cgroups manual page nowadays, which has a lot of useful information in it. So what were some of the problems with Cgroups version 1? The general idea of Cgroups version 1 is you could have multiple hierarchies. In Cgroups version 1, there are currently 13 different controllers, and in theory, you could attach each controller to a different hierarchy. And the idea of this scheme was to let you have complete flexibility. You could have individual controllers attached against individual hierarchies, or you could have multiple controllers attached to a single hierarchy, whatever you liked to do. That was the theory, at least. So be super flexible. But it turned out being that flexible wasn't, in a practical sense, useful for most people. And having that degree of flexibility actually created some complications. So I'm going to just briefly consider 2 possible approaches that you could take with Cgroups version 1 and just talk about the trade-offs between these different approaches. And one possibility is you can put each controller against a separate hierarchy, or you could mount multiple controllers, perhaps all the controllers, against a single hierarchy. So here's the situation we have if you've got individual controllers mounted against individual hierarchies. And here I've just taken a couple of examples, the memory controller and the CPU controller. And what we've got here is a bunch of Cgroups with some processors in them, P1, P2, P3, P4. Now, if we do things this way, then with the memory controller, we can do fine-grained allocation of memory, say, to process P2 versus processes P3 and P4. We can make individual decisions about those 2 different groups of processes. On the other hand, for the CPU controller on the right-hand side, we've put P2, P3, and P4 into the same C group they can share an allocation of CPU. And this might be desirable. We might know that perhaps at some time process 1 needs more CPU time, process 2 needs less, and we're happy just to share an amount of CPU time for those 3 processes as a group. So it's actually desirable to have less granularity of the kind of control that we want for CPU, whereas for memory, we might want, hypothetically, finer-grained control. So the advantage of this approach is we can have different levels of granularity for the control with different controllers. Greater granularity in this case for memory, less granularity for CPU. The downside of this approach is, suppose we're trying to maintain roughly parallel hierarchies and we want to move process P2 from cgroup N, rephrase that, move process P2 into cgroup M. Now that means we're going to have to do the operation on multiple hierarchies. We're going to have to do the operation for the memory hierarchy, repeat it for the CPU hierarchy, repeat it for all of the other hierarchies that we're maintaining. Because commonly, what you want to do in this sort of situation where you've got differing levels of granularity is keep roughly parallel trees, just with different levels of granularity, and when you do a move operation to move a process, you need to repeat it everywhere. So this is kind of cumbersome, it's kind of slow, and it's certainly not atomic. Okay, the converse approach is we can create, we can bind multiple controllers against the same hierarchy. So here we've got a hierarchy with CPU and memory both attached to the same hierarchy. The advantage of this approach is if we want to move a process to another C group, we just do it once. Okay, there's only one hierarchy involved. The disadvantage is we no longer have differing levels of granularity of our control. Now when it comes to doing management of CPU, we need to make specific decisions about how much CPU we're going to give to process P2 versus P3 and P4. And we might not actually want to do that. We adopted this particular arrangement of groups because we wanted fine-grained granularity for the memory controller, but that also forces us now to make fine-grained decisions for the CPU controller, which, as I say, we may not necessarily want to do. Okay, there were other problems with this version 1 hierarchy scheme as well. There are certain controllers called sometimes utility controllers, like the freezer controller. Freezer controller lets you freeze a group of processes. Now suppose, hypothetically, you've got a bunch of processes that are chewing up a lot of CPU time. They're in a certain CPU C group, and you want to freeze all those processes so they stop consuming CPU time. How do you do that? Well, you can't freeze a CPU C group. You freeze the group of processes that are in a freezer C group. In other words, you need to have a freezer C group whose membership corresponds, matches your CPU C group. And the same thing for all of the other kinds of C groups, memory or block I/O, whatever, that you might potentially want to freeze for some reason. There needs to be a corresponding grouping in the C group, in the freezer hierarchy, so that you can freeze that group of processes. Now, what that means is, this kind of constraint means that typically what you want to do is maintain either all controllers on the same hierarchy or have closely parallel hierarchies for all the hierarchies. So the way it turned out in practice with cgroups version 1, people didn't need the super flexibility that was possible with cgroups version 1, where you could have completely orthogonal hierarchies that had different arrangements of processes. What people mostly needed was similar hierarchies, but with differing levels of granularity for different controllers. And so that's the way people use cgroups version 1. You had a bunch of separate hierarchies so you could do different levels of granularity of control, but some of the hierarchies did finer granularity than others in certain parts of the hierarchy. So With Cgroups version 2, this whole notion of separate hierarchies was thrown out the window. There's now just a single hierarchy. All the controllers are available in that hierarchy, and there's an additional mechanism which allows you to control granularity. So you can say that you want to manage CPU down to a certain level in the hierarchy, but you want to manage memory to a deeper level in a certain part of the hierarchy. Okay. Now, another problem with Cgroups version 1 is, with Cgroups version 1, you can have thread-level granularity for Cgroups membership. You can have a multi-threaded process where some threads were in one Cgroup and other threads were in a different Cgroup. Now, for some controllers, this made no sense. For example, I'll step back a second. For some controllers, it did make sense. For things like the CPU controller, there were use cases. But there are other controllers for which it makes no sense. The memory controller is the most outstanding example. It doesn't make sense to put different threads of the same process in different memory Cgroups because threads share an address space. How could the threads possibly be subject to different memory controls? So in version 2, at least initially, there was only process-level granularity for Cgroup membership. In other words, all the threads of a multi-threaded process must be in the same Cgroup. Now, starting in kernel 4.14, about a year ago, there's been some backtracking on that decision, and now there's a limited form of thread granularity. I'll come back to that if I've got time. Okay, some other problems with Cgroups version 1. In Cgroups version 1, you can have a Cgroup that both contains tasks, threads or processes, and has child Cgroups. Now, this isn't problematic in itself, but the problem is that if you have a Cgroup that has some member processes and some child Cgroups, different controllers understood that situation in different ways. Some of the controllers understood it as being the processes are equal competitors to the sibling Cgroups, whereas some of the other controllers understood it as being the processes are competitors to the member processes of those sibling Cgroups. Neither interpretation is wrong, but the fact that you had different controllers that understood the situation differently meant that if you're trying to use parallel hierarchies for different controllers and they understood the hierarchy to mean different things, it made it difficult to do parallel hierarchies. So the rule then in version 2 is roughly only leaf Cgroups can have member processes. Interior nodes, interior Cgroups can't have member processes. The story's a little bit more subtle than that. I'll come back to it. Okay, another problem with Cgroups version 1 was just a question of random inconsistencies. There were 13 different controllers, in many cases designed by different groups of people to scratch their own itch, and they didn't necessarily look at what other people had done with their controllers. They just made up their own decisions about interface design. So there was a lot of random differences between the various controllers. Some of the controllers had, you could do control in the root Cgroup, others you couldn't. Some of the magic values that were used in certain Cgroup files were simply inconsistent. In some Cgroup files, if you want to say unlimited, you wrote -1 into the corresponding file. In some others, you wrote the string max. This is just because different people designed the APIs, didn't look at what other people had already done. So the idea is with version 2, there's a set of documented, consistent rules about how these interfaces should be designed. And I don't have it there on the slide, but I think the really important thing is nowadays there is an overall manager for the design. There is a Cgroups version 2 maintainer who should be making sure that everyone follows the rules. Some other problems with Cgroups version 1. Cgroups version 1 has a mechanism called release notification. This is a useful feature. It enables you to find out you've got a certain Cgroup that has some processes in it, and maybe all the processes terminate and there's no process left in the Cgroup. Now when that sort of thing happens, you might want to do something. Perhaps, for example, if you're system D and this C group contained a daemon that you'd started, if that daemon terminated accidentally, you might want to restart the daemon. Well, release notification is a feature provided by Cgroups version 1 to support that use case. The idea is that when a C group becomes empty, you get a notification and then you can do something in response to that C group becoming empty. Now, the problem with release notification in version 1 is it was done in a really expensive way. When a C group became empty, the kernel magically fired up a process, and that process got some information about which C group became empty, and it would do whatever is necessary in response to that. The problem is, if you have thousands of C groups becoming empty per second, that's thousands of processes per second. So it's a really expensive way of getting notification. So version 2 has a much more lightweight solution for this problem. Okay, so then we've got some controllers in Cgroups version 2. And up until fairly recently, the story was a bit sad. And what I mean by that is there were a lot of controllers that weren't yet available in Cgroups version 2. But we're getting pretty close to having a full set of controllers in Cgroups version 2 now. There's one or two that are still missing, but as of fairly recent kernels, we have most of the controllers that we want. Some of those version 2 controllers are exactly the same as the version 1 controllers. Typically, that's because these version 2 controllers, or these version 1 controllers, were added recently while version 2 was being developed, and things were just done in a consistent way. But some of the other controllers are significant rewrites of the version 1 controllers because we learned from the mistakes in version 1. As I said, there is a kernel documentation file that does talk about these various controllers. I'm not going to try and run through the various controllers. You can check these slides later, but there are equivalents for most version 1 controllers. I'll just mention CPU was an interesting case because that was only supported in kernel 4.15 about a year ago, and the lack of that controller was quite a roadblock for Cgroups version 2 adoption. And then other than that, what we're still currently missing, so let me go back a second. Yes, so kernel 5.0 about to be released in a few weeks' time, that added one of the last remaining controllers, CPU set controller. Currently, what we don't yet have is the freezer controller. I'm not quite sure why. It's been coming along soon now for about 2 years, but it should be there soon. And that's pretty much the last controller that's going to be moved from version 1 to version 2. There is one other controller in version 1, the huge TLB controller, but from what I understand, it won't be moved to version 2, and that's because it's considered there is better ways of managing huge page allocations than using Cgroups nowadays, so it won't be added to Cgroups version 2. Yes, so this is true. Some of the controllers in version 2 don't yet have all the features of version 1. So far we're being conservative, I think. I think the idea is, yes, some features will be added in the future as the use cases are proven. Same thing is true of the CPU set controller, by the way. It's a much reduced functionality from version 1, but pieces will be added according to proven use cases, I think. Okay, so if we want to use Cgroups version 2, because it's a complete rewrite, I'll back up a second. Of course, Cgroups version 1, it's implemented using a pseudo file system. Well, Cgroups version 2 is as well, because it's completely a complete rewrite of Cgroups. For Cgroups version 2, the pseudo file system is a different file system. And the kind of file system we have to mount, we say mount-t cgroup2, a Cgroup version 2 file system, source of the mount, which is just any random string because it's a pseudo file system, and our mount point. You need to do that if you want to use Cgroups version 2. You probably don't have to do that, because if you're using a modern system that uses systemd, which is most of us, then systemd creates a certain mount point for you already for the Cgroups version 2 hierarchy. And it's mounted at sysfs cgroup unified. When this mount point is created, all the controllers are automatically available under that hierarchy. Now this is different from Cgroups version 1. When you mount a certain hierarchy, you use a -o option to say, I want a certain controller attached to this hierarchy. This is not necessary with Cgroups version 2. When you mount the Cgroups version 2 file system, all the controllers are, potentially at least, automatically available. Now, when you mount the Cgroup version 2 file system, then in each of the Cgroup directories under the file system, there's a cgroup.controllers file, and this tells you what controllers are available in the version 2 hierarchy. But if you do this on your system now, for example, you might find that when you go and look in that cgroup.controllers file, you'll see something like what I'm showing here, where you cat cgroup.controllers in the root directory, and it has no controllers listed. There are no available controllers. Now, the reason for that is because all of the controllers are currently being used in version 1. And you can't use controllers in both version 1 and version 2. If you want to use the controller in version 2, then you have to unmount it in version 1. So the way to do that, of course, is you say umount sysfs cgroup and then the name of the hierarchy you want to unmount. Here I said unmount the PIDs hierarchy. And once I've done that, now I've looked in cgroup.controllers in the unified hierarchy, I can see the PIDs controller is available. Now, you might try doing this on your system at this point, and you'd find that when you did the umount and then catted this cgroup.controllers file, the PIDs controller is still not available. And the reason for that is you can only successfully unmount a version 1 hierarchy if all the processes are in the root cgroup, there are no child cgroups, and no process has a current working directory or an open file descriptor that refers to an object inside that hierarchy. And systemd, for instance, creates a lot of stuff in the various hierarchies. So if you want to unmount the hierarchy, you have to undo everything that systemd has done, for example. So you have to go through these steps, moving all the processes into the root cgroup, removing all the child cgroups, doing this from the bottom up, because you can only delete child directories, well, you can't delete parent directories until you delete child directories, and so on. It's a slightly cumbersome process. I've got a little script there that you can take a look at that just takes you through the steps. And this mostly works. One controller this script doesn't work for is the memory controller. For some reason, even when I try this script on the memory controller, it doesn't unmount. I don't quite know why. I've got a suspicion it's something to do with an event FD mechanism that's involved with the memory controller. The point is, you have to do this work in order to unmount the file system, and even then sometimes it doesn't do the job for you. So what do you do then? Then what you need to do is reboot your kernel with a certain kernel boot parameter. And the kernel boot parameter is cgroup no v1 equals, and then a list of version 1 controllers that you want to disable. Or if you want to disable them all, then you put the word all. Now, when that happens, systemd feels slightly sad, but it copes. It says, okay, I'm on a system that doesn't have cgroups. There are systems like that, and it just lives with it. Actually, nowadays, systemd can understand quite a bit of cgroups version 2. But the point is, systemd can live, if it has to, without cgroups. If you reboot your kernel in this way, then when you reboot, you will probably see in the cgroup.controllers file a bunch of controllers, okay? And this is because none of those controllers are mounted in version 1 hierarchies. Now, I should step out. I'm going to stay with the shell session for a moment. What the cgroup.controllers file is telling us is what controllers are available. If we want to use a controller, we actually have to enable it. Now, there's another file called cgroup, subtree control, which tells us which controllers are currently enabled. Now, what I'm going to do here, I'm in the root cgroup. I'm going to create a couple of child directories, A and B. Look inside A. We see there's a few files there. These are mainly files to do with management of cgroups themselves, so they've all got the prefix cgroup. And as I say, if we look in cgroup.subtree control, there are no controllers enabled at the moment. Now, what I'm going to now do is say, well, let's enable a controller. Now, the way you do this is you say echo and then plus some controller name into the subtree control file. That enables that controller. If I want to disable a controller, I can say echo minus PIDs plus memory. Okay, and then now the memory controller is enabled, the PIDs controller is being disabled. Now, this is one area that cgroups version 2 is very different from cgroups version 1. What I'm doing here is enabling controllers or enabling control for the next level down in the hierarchy. Now, I'm just going to reverse that change, disable memory, and just repeat. There's the contents of a child directory A. There are no controller-specific interface files there present at the moment. But if I turn around and say enable memory, and then look in subdirectory A, now I've got a whole lot of files prefixed with the string memory dot. These are the controller interface files for the memory controller. They sprang into existence when I enabled the memory controller in the parent cgroup. And likewise, if I do the same thing for PIDs and we look in A, we see now a bunch of PIDs files in the child directory. And of course, we'd see the same thing in the directory B as well. Okay, so this is, as I say, a significant difference between cgroups version 1 and version 2. This subtree control file is allowing us to enable or disable controllers control at the next level down. And this is the mechanism, by the way, that allows you in cgroups version 2 to have different levels of granularity for the different controllers. You can enable a certain controller to some depth in the tree and then maybe not enable it at any lower levels, while for another controller, you enable that controller at deeper levels in the tree. So you can have differing granularities for different controllers. Okay, so those attribute files that appeared in the child directories A and B, things like memory, memory.max and PIDs.max, these are being used from the level above to control PID allocation, memory allocation in the lower level cgroups. Okay, now I just want to check that this is just pretty much covering what I've just talked about. Just want to make sure I haven't missed anything. Okay, now one of the other things that we can't, I'm going to just go a little further here. So if I say cat cgroup.controllers subtree control. We've got memory and PIDs enabled. What about if I say cat a/cgroup.controllers? The next level down, what controllers are available? Any guesses? Memory and PIDs, okay. And what about subtree control? Empty, okay. These controllers are available at the next level down, but they haven't been enabled at the next level down. So if I now said make dir, say a/xxx, and then I looked in that directory, okay, we don't see any of the memory or PIDs files because in a/cgroup.subtree control, the controllers haven't been enabled. But if I did then turn around and say echo plus PIDs into a/, and then I looked inside xxx, then we see the PIDs interface files. Okay. Oh, and then there was one other thing I wanted to say there, which was, well, now let's suppose that into A, we tried to put CPU. Okay, in that case we get an error because we're trying to enable a controller that isn't available at this level. Because if we look in cgroup.controllers in that directory, okay, I should have said, excuse the mic noise there. Okay, we've only got memory and PIDs available. Okay. Now, one of the things that's going, or one other thing here is if you've got a controller, this just follows on from what I was saying about granularity before. If you've got a controller that's disabled at a certain level, then you can't enable it at any lower levels. Okay, so in the particular case that we're looking at there, we can't have CPU enabled at any lower level because it wasn't enabled at a level above. Alrighty. Now, in terms of placing processes in C groups and organizing C groups, things are otherwise pretty much the same as in version 1. You can organize your hierarchy as a set of subdirectories. To begin with, all processes are in the root C group. There's the cgroup.procs file. You can write PIDs in there, and that'll move a process into that C group. You can read that file to find out which processes are in the C group. When a child process is created, it's in the same directory, the same C group as its parent. And if a C group is empty, in other words, it contains no non-zombie processes and no child C groups, the C group can be removed. But there are some differences as well in version 2. In version 2, the root C group doesn't contain any controller interface files. In other words, you can't do control on processes that are in the root C group. With version 1, for some of the controllers, you could do control in the root C group. For some others, you couldn't in version 1. Version 2 is consistent. There's no control of any sort in the root C group. A C group in version 2 can't both have member processes and control C group child directories. I'll come back to that in a moment. And in version 2, at least to begin with, there was no concept of thread level granularity. If you have a multi-threaded process, all the threads must be in the same C group. Now I just want to come back to one of those points, one of those points of difference there. A statement that I made earlier, only leaf nodes in this version 2 hierarchy can contain member processes. Or putting it another way, a C group can't both have child C groups and member processes. The rules are a little bit more subtle than that. A C group isn't allowed to both have child processes and enable controllers. In other words, write the names of controllers into the cgroup.subtree control file in that C group. So it's not the actual presence of child C groups that's an issue, it's enabling controllers in the C group. You can't do that and have member processes in the C group. Or to put things in a couple of other ways, a C group can have member processes and child C groups if you don't enable controllers, or to put things another way again, if you have a C group that has child C groups and member processes, then before you enable the controllers, you need to move the processes somewhere else, perhaps into child C groups, for example. This rule changes for certain controllers in kernel 4.14. Okay, I've got a few more minutes, so I'll go a little bit further. Okay, so release notification in version 2. The problem with version 1, we had release notification, a way of finding out if a C group becomes empty, but the way we got this notification was really expensive. A process was fired up every time a C group becomes empty. This is expensive. Also, another limitation of this mechanism is you could only have one kind of program being used as the notification program for the entire hierarchy. You couldn't have different notification programs being used for different parts of the hierarchy, which could be useful from a container perspective. So Cgroups version 2 does things completely differently. Instead, nowadays, there's, in each cgroup directory, there's a file called cgroup.events. It's a key value file. At the moment, there's only one key there. It's one called populated, and that key populated has the value either 1, meaning there is one or more processes in this sub-hierarchy, or 0, meaning there are no live processes in this sub-hierarchy. And then you can monitor that file using either iNotify or poll or repoll or select, and if the file changes, in other words, a C group becomes populated or depopulated, you get a notification. Different kinds of notification, obviously, for iNotify versus poll and epoll. So now you can have one process that monitors multiple cgroup.events files, and that process can be pre-created. It doesn't need to be created when the C group becomes empty. So this is a much cheaper way of doing notification, and also you can do delegation of the notifications. In other words, you can have one process monitoring a certain part of the hierarchy and a different process monitoring another part of the hierarchy. Perhaps these two different hierarchies can correspond to two different containers, for example. Okay, I've still got a few minutes. Okay, delegation. In a way, delegation is sort of a new feature in version 2, though it existed in version 1, but not in a very well-designed way. Now, what I mean by delegation is, I haven't quite explicitly stated it, but you know, the C group hierarchy is owned by a superuser. If you want to change the contents of files in that hierarchy, you have to do it as a privileged user. It could be desirable to have some part of the hierarchy, a C group hierarchy, a C group version 2 hierarchy, that is delegated to a non-privileged user. Perhaps, for example, because that piece of hierarchy is being used by a non-privileged container being run by UID 1000, for example. So delegation is the idea of passing ownership of some part of the C group version 2 hierarchy to a non-privileged user, so that user can do management of the sub-hierarchy. Just a bit of terminology here. I'll talk about when I talk about the delegator, I mean the privileged process that is managing the parent of the sub-hierarchy, and delegatee, I mean the less privileged process, perhaps, for example, UID 1000, that is being assigned control of some part of the hierarchy. So the way of doing delegation in Cgroups version 2 is the delegator gives the delegatee write access to certain files in the C group hierarchy. The usual way of doing this is just change the ownership of those files to be the ownership of the to be the same user ID as the delegatee. There's various files whose names you need to change. There's various files, whose ownership you need to change: cgroup.proc, cgroup.subtree control, cgroup.threads potentially, possibly some other files as well. The ownership of those files needs to change, but there's certain files whose ownership shouldn't change. In particular, the resource control interface files should remain writable by the resource control interface files shouldn't be owned by the delegatee because they're being used from the level above to distribute resources into the sub-hierarchy. So in terms of a picture, in version 2 you set things up like this. The stuff that is in blue solid lines here, these are the files whose ownership gets changed to being the delegatee, let's say UID 1000. So the cgroup directory itself gets changed, the ownership gets changed, and also things like cgroup.procs and cgroup.subtree control. But what doesn't get changed is the ownership of these resource control files because they're being used from the level above to control the resources that are being distributed into this cgroup. So things like PIDs.max, CPU.max. And of course, as the delegatee, the unprivileged delegatee creates new child cgroups under the hierarchy, those child cgroups are automatically owned by the delegatee. Okay, now after delegation has been done, in other words, after this ownership has been changed, the delegatee can create sub-hierarchy, create child directories, move processes around inside the delegated hierarchy, subject to certain rules, certain so-called delegation containment rules, which basically say the delegatee can move processes around within the delegated hierarchy, but not move processes outside the hierarchy, into the hierarchy, or inside the hierarchy, outside the sub-hierarchy. Of course, at this point, people ask, might ask, well, what about delegation in Cgroups version 1? Well, it kind of existed, but it kind of existed by accident. It wasn't designed. Okay, but what I want to say is there were certain pieces of it that weren't designed as such because we didn't have proper delegation containment. Yeah, we can talk about it later. So I'm thinking, you don't get proper containment when it comes to different containers owned by the same user. That's the critical point that I want. I know it's too much detail that I want to go into now. The point is you don't get proper containment, but we can talk about it. I'm out of time, aren't I? 1 minute. If someone wants to ask me about thread mode afterwards, they can. Or I'll take 1 minute of questions now. Yes?
Yeah, so because...
I can repeat the question.
No. Follow this. You mentioned that leaf node, if you contain actual things in a leaf, you can't contain a sub-hierarchy? Sorry, if there's processes...
That's how the rule is roughly expressed. The rule, as I tried to more precisely explain it, was you can't both have member processes and enable controllers.
Okay, so I was just thinking of, does that mean that there's no way to atomically sort of move something to a child of a tree? Like if you've currently got a process in a C group, yep, there's no way to move it to a child of that location.
So I guess what you're asking is, you've got a C group that's got some member processes. You want to create some sub-hierarchy under there, move those processes there. Well,
but you can't make them if you've already got a process, but then you can't move them.
You can't enable the controllers until you've moved the processes elsewhere. Okay? You can create the child C groups, move the processes into the child C groups, and then enable the controllers.
You can't create subtrees.
I'm sorry, I missed that last piece.
It's just that you can create the subtrees, you just can't enable the controllers until...
Yes.
Okay.
Another question behind there, but I better...
Can delegatee be a Unix group?
I'm sorry, see again, please?
The delegate for the delegation, can the delegate be a Unix group rather than Unix user?
I think in theory, yes, but in practice, I don't see that being done. But really what you need to do is give right access. Okay, the way that people typically do that is by changing the ownership, the user ownership. I think I better wrap it up there, yeah?
We've run out of time.
Okay.
Thank you very much. Round of applause, please.